Greetings to all. Myself Vaishnavi, Assistant Professor, IT Department from SNS College of Engineering. Now we are going to see about the computer system architecture and the operating systems. First one is a computer system architecture. Most system uses a single general purpose processes, and also most systems have the special purpose processes as well. That is multi-processor systems growing in use and importance. That is also known as that parallel systems are the tightly coupled systems. Here we have the advantages of that multi-processor systems that include that increase the throughput, economy of the scale, and the increase the reliability. Increase reliability, that is graceful for degradation or the fault tolerance. Next one, we have the types of multiprocessing. Here we have the two types of multiprocessing. First one, asymmetric multiprocessing. Second one, symmetric multiprocessing. First one, asymmetric multiprocessing. Each process is assigned as a specific task. Next one, symmetric multiprocessing. Each process is assigned to one common task. Next one, symmetric multiprocessing architecture. We have the diagrammatic representation of this symmetric multiprocessing architectures. Each CPUs are interconnected to that memory. Here, each CPU contains the registers and the cache. Registers are the storing devices. It contains the small storing devices. Next one is a dual core design, that is multi-chip and the multi-core. System contains all the chips. System that containing the multiple and the separated system. Here we have the CPU core 0 and the CPU core 1. Here inside the CPU core 0 we have that registers and the caches. As it's same for the CPU core 1, we have the registers and the cache, and this CPU cores are interconnected to the common memory. Next one is cluster systems. Like the multiprocessor systems, but multiple systems are working together. That is usually sharing the storage via the storage area network, that is SAN. Next one, provide high availability service which survives the failure. In clustering systems, we have the two types, that is asymmetric clustering and the symmetric clustering. Asymmetric clustering has the one machine in the hot standby mode. Next one, symmetric clustering has the multiple nodes running applications monitoring each other. Next one, some clusters are for the high performance computing, that is HPC. That applications must be written to use the parallelizations. For this we have the diagrammatic representation. That is one, we have three computers that is interconnected with each other, and it is commonly connected to the storage area network, that is SAN. Next one, we have the operating system structure, that is multi-programming, that is batch systems needed for efficiency. That is single user cannot keep the CPU and input output devices busy at all the times. Multi-programming organizes the jobs, that is code and data. So CPU always has the one to execute. Next one, a subset of the total jobs in the system is kept in memory. That is, one job is selected and run via the job scheduling. Next, when it has to wait for input output, for example, OS, that is operating system, switches to the another jobs. Next one, time sharing, that is multitasking, is logical extension in which the CPU switches the jobs so frequently that users can interact with each job while it is running, creating, and the interactive computing. Here we have the 5 points for this multitasking. First one is response time. That response time should be less than 1 second. Next one is each user has at least one program executing in the memory, that is process. At least one process is ready for the executing. Next one, if the several jobs ready to run at the same time, that is CPU scheduling. Next one, if the process don't fit in the memory, it swaps them, moves them in and out to run. Fifth one is virtual memory allows the execution of the process not completely in the memory.